Hey everyone, and welcome. Today we're diving into a pretty technical but super interesting challenge for the Bitcoin network. It's this thing called digital dust. Now, it might sound tiny and insignificant, but as you're about to see, its impact, well, it's a whole different story. So let me just ask you this to get started. What if a microscopic amount of value, we're talking fractions of a penny, could actually jam up the gears of a massive worldwide financial system? It sounds kind of like something out of a sci-fi movie, right?
Yeah, well, in the world of Bitcoin, this isn't science fiction at all. It's a real, ongoing technical challenge that people deal with every day. And that tiny, annoying little speck of value, it's got a name. We call it digital dust.
Okay, so to really get our heads around what dust is and why it's such a big deal, we need to pop the hood on a Bitcoin transaction really quick. We're just going to focus on two key ideas: outputs and Satoshis. Every single Bitcoin transaction has inputs and outputs. The easiest way to think about it is inputs are where the money comes from, and outputs are where the money is going. So each output is just a specific chunk of Bitcoin being sent off to a new address. Simple enough? Now, because we're talking about these incredibly small amounts, we can't really speak in terms of whole Bitcoins. It just doesn't work. Instead, we have to use the smallest possible unit, the Satoshi. And there are 100 million of these in a single Bitcoin. That's the level of detail we need to be on to really understand dust. All right, so now that we've got that down, we can get to the real heart of the issue, the uneconomical output. It sounds a bit technical, but it's a really simple idea. It's money that literally costs more to spend than it's even worth. So an output becomes uneconomical when the value it holds, the number of Satoshis, is actually less than the network fee you'd have to pay to spend it. I mean, imagine you find a penny, but your bank says it's going to charge you $1 to deposit it. You just leave it there, wouldn't you? It's the exact same principle. And this lays it out perfectly. On one side, you've got the actual value of the little chunk of Bitcoin. On the other, you've got the fee it costs to move it. When that value on the left is lower than the fee on the right, that money is basically frozen. There's just no financial reason for anyone to ever touch it again. And that's it, right there. Those tiny, stranded, uneconomical outputs. That is precisely what we call digital dust. They're just the leftover crumbs from old transactions, too small to ever be worth cleaning up. Now, at this point, you're probably thinking, so what? It's a fraction of a penny, who cares? But see, when you scale this problem up to a global network that's handling millions of transactions, a tiny bit of dust suddenly becomes a huge, huge problem. And to be clear, a single piece of dust is totally harmless. It's just one tiny, forgotten piece of data in this gigantic digital ledger. By itself, it doesn't affect anyone. The issue is what happens when they pile up. When you get millions or maybe even billions of these dusty outputs accumulating across the network, they start to create a really significant and permanent weight on the whole system's infrastructure. So here's why that really matters. Every computer that runs a full Bitcoin node, and these are the machines that keep the whole network secure, has to keep a running list of every single spendable piece of Bitcoin. Dust gets added to this list, but because it's worthless to spend, it never gets taken off. It's a forever burden that just bloats the system, which makes it more expensive for people to run these nodes. And that right there threatens the decentralization that makes Bitcoin what it is. So how does the network fight back? I mean, it can't just sit there and let this digital dust pile up forever. Thankfully, the core software has a really clever defense mechanism built right in. To keep the whole network healthy and running smoothly, Bitcoin nodes enforce something called a dust policy. You can kind of think of it like a filter, or maybe a bouncer at the door, for every new transaction that tries to come through. So the dust policy is basically a set of rules that tells the node, hey, if you see a transaction that's just creating more of this worthless, uneconomical dust, just reject it. If a transaction looks like it's making the problem worse, most nodes will just refuse to pass it along. It's a really proactive way to keep the network from getting cluttered. So to put a real number on it, a lot of wallets and nodes use a pretty common threshold. It's not an official rule, but it's widely used, 546 Satoshis. Any new transaction output that's worth less than that is probably going to be considered dust and just get rejected by the network. But hold on, the story doesn't end there. Like a lot of rules, this one has a really fascinating and honestly a pretty brilliant exception, one that actually opens up a whole new world of storing data right on the blockchain. And this is where things get really clever.
See, the whole point of the dust policy is to stop spendable outputs from clogging up the system. But what if you could create an output that you knew with 100% certainty could never be spent?
Well, you can, and it's done with a special command called OP_return. Its entire purpose isn't to move money around, but to embed a little piece of data directly into the blockchain. And the key, the absolute magic of it, is that it creates an output that is provably unspendable.
So here's how the trick works. A transaction creates an output that has zero value, and it sticks in that OPR return command. This basically shouts to the entire network, hey everyone, you can ignore this one. It can never be spent. And since the nodes know that, they don't have to add it to their big database of spendable coins. So the data gets stored on the blockchain forever without creating any of that burdensome digital dust. Pretty smart, right?
The OPR return solution is awesome, and it shows just how adaptable the network can be. But the fight against dust and what we call blockchain bloat is far from over. It's really an ongoing challenge that needs constant innovation.
It's this constant balancing act, you know? On one hand, you want the network to be open and cheap for everyone to use. On the other, you have to protect it from getting bogged down. Developers are always working on new solutions. There's a really cool one called Utrexo that aims to completely change how nodes track this stuff to dramatically shrink the burden on them. And really, that leaves us with this final, fundamental question that's at the heart of so many design choices in Bitcoin. How do you keep a system lean, efficient, and decentralized, while also keeping it open and permissionless so anyone in the world can use it? Finding that perfect balance is the name of the game. Thanks for tuning in.